All right, welcome to part two for dividing with radicals. I'm going to talk about something called rationalizing the denominator. Before we get into what that is, I have to point out the second rule here that we talked about earlier. Okay, so that is you cannot leave a radical in the denominator. And for more on why you cannot, I have a video recording for you guys. You can watch that as a bonus. Um, but you can't. You cannot leave a radical in the denominator. So what happens if you end up with a radical in the denominator? What do we do then? Okay. In that case, we do this process called rationalizing the denominator. Again, denominator means the bottom of a fraction, right? Denominator. So rationalizing is the process of getting rid of radicals in the denominator, again, in the bottom. All right, so let's take a look at our very first example here. I have radicals, square root of 3 over 2. Remember from the last lesson, the last video, we can take this and split it up into square root of 3 and the square root of 2. But that doesn't help me. I cannot simplify the square root of 3. I cannot simplify the square root of 2. Okay, I'm kind of stuck because now I'm breaking one of my rules. There's a radical in this bottom here. So what can I do? Here's the process, all right? And let me write this down. There it is. You can multiply the top and the bottom by the radical that you want to rationalize. You're going to multiply the top and the bottom by the radical, basically, that you want to get rid of. In this case, I'm trying to get rid of this radical down here, this square root of 2. So what I'm going to do is I'm going to multiply the top by radical 2 and the bottom by radical 2. Okay? And if you think about why this works, think about what 2 over 2 is. Isn't that just 1? This is essentially like saying I'm multiplying my fraction by 1. And what happens when you multiply something by 1? Nothing. Nothing changes. The value stays the same. So it's kind of like what we do when we're trying to get a common fraction, a common denominator, so that we can add fractions together. But in this case, I'm multiplying with a radical. All right, so anyways, off on a tangent. Here we go. I multiplied the top and the bottom by the radical I want to get rid of. So what does that become now? On top, radical 3 times radical 2 is radical 6. And on the bottom here, we have radical 4, which is great because the square root of 4 is a perfect square. The reason I did this is so I can get a perfect square so that I can simplify it. Right? What is the square root of 4? Isn't that just 2? On the top, I can't do anything with the square root of 6. I can try to split it up, but nothing will simplify that. And there we go. I'm done. This is my simplified form of the radical 3 over 2, right? So let me just check my rules. I don't have any fractions inside a radical. And again, there's no more radical in my denominator. Everything is all good. This is as far as we can go. So that's the key here. You need to multiply the top and the bottom by the radical that you want to get rid of, the radical you want to rationalize. Here we go. Let's take a look at another example. So I'm going to scroll again. You know what? I can just bring this up. How do we do this? We want to multiply the top and the bottom by the radical you want to rationalize. All right, so here we go. I have another example. Square root, radical, of 8 over 14. Now, before you go and split this, I do notice something. Hey, I can reduce the fraction. So before I do any sort of splitting, I can reduce 8 and 14. So I'm going to go ahead and do that. That way I get some smaller numbers here. So if I divide by 2, I get 4 and 7. Now I can take this and I can split it up. Square root of 4 on top, square root of 7 on the bottom. Hey, check that out. The 4. This square root of 4 can simplify. You know what? I might as well simplify anything that I can. Makes my numbers easier, hence the word simplify. So if I take this, square root of 4 is just 2, and I have the square root of 7 on the bottom. All right, but wait. I cannot leave a radical in the denominator. We can't leave that like that. We can't have an irrational number down there. So what do? I need to rationalize it. We are going to take the top and the bottom and multiply it by square root of 7, the thing we're trying to get rid of. So now we're rationalizing. All right, so what does this make? If I think about this, on the top, on the outside, we have 2 times the square root of 7. But here on the inside, 7 times 7 is 49. And that's great. In fact, that's perfect. It's a perfect square. It's 49. The square root of 49 is just 7. This simplifies to 2 square root of 7 over 7. Right? 49, the square root of 49 is 7. And there we go. I'm done. Can I reduce the 7 and the 7? No, because one's on the inside of a radical, one's on the outside of the radical. I can't do that, so I can't simplify that any further, so I'm going to back that up a bit. This is it. This is as far as we go. All right, let's take a look at a third example here. I've got something a little bit more complicated for you guys to look at. 9 over 12 radical 6. Before I even begin, the first thing I noticed is that I can reduce this fraction. Again, which numbers can I reduce? Only the 9 and the 12. Well, why not 9 and 6, Miss Lee? Because 9 and 6, one's on the outside, one's on the inside. Can't mix and match. But 9 and 12, they're both outside the radical, so we can simplify that. So I'm going to go ahead and reduce by 3. So that would be 3 over 4. And I'm bringing over my rad 6, square root of 6. All right, so I'm staring at this, and I see a radical in the denominator. Cannot have that. So I need to get rid of it. Now I'm going to rationalize it. And how do I rationalize? Rationalize this by multiplying by the square root that we want to get rid of. In this case, square root of 6. Miss Lee, what about that 4 in front? Do I have to multiply by 4? You could if you want to, technically, but you're creating more work for yourself because at the end of the day, it'll end up reducing, kind of like a fraction. So you could multiply the whole thing by 4 radical 6. You're just going to end up doing more work. In this case, make it simpler. Just multiply by radical 6. All right, let's do that and see what we get. We get 3 radical 6 on the top. And on the bottom, I get 4 radical 36, 6 times 6. And this is great. This is the reason why we do this, is because we end up with a perfect square. The square root of 36 is just 6. So this ends up being 3 radical 6 over 4 times 6. All right, things are getting a little long here. I'm going to start writing things going downward. Again, let's see, 4 times 6, well, that's 24. So this is just 24. And again, I can reduce 3 and 24. That's 1 over 8. So this just becomes 1 over 8. Right, I could put the 1 in front. I don't need it. And there we go. Can I reduce the 6 and the 8? No. One's inside the radical, one's outside. So this is actually as far as we can go. All right, on to my last problem here, right? So keeping organized. One thing that you've noticed since we're working with fractions is always to look to reduce. That helps. That way you don't have to deal with such large numbers. So in this case, I have 5 radical 20 over 6 radical 30. 5 and 6, I can't reduce that. But 20 and 30, I can reduce those. I can reduce that by 10. So if you think about what this becomes, I now have 5 radical 2 and 6 radical 3. All right, all I'm doing here is reducing. All right, now I'm stuck because I cannot have this square root, this radical in my denominator. Can't do that. So how do I get rid of it? Again, we're going to multiply top and bottom by that square root. In this case, radical 3. Multiply top and bottom by radical 3. That way we get rid of it. Here we go. Let's see. What does this become? We end up with 5 on the outside. And if you think about on the inside, we have 2 times 3, which is 6. On my bottom here, my denominator, we have 6 on the outside. And inside the square root, 3 times 3 is 9. Hey, this is great because the square root of 9 is 3. We can reduce this. We can simplify this. The top stays the same, but my denominator is now 6 times 3 outside of my square root. 6 times 3 is 18. I'm going to bring down 5 radical 6. Haven't done anything with that yet. And let's see. Is there anything to reduce? Can I reduce 6 and 18? No. Because again, one's inside the square root, one's outside the square root, so can't do that. That's it. This is the simplified form of the expression we had before. All right, so there we go. What you're always looking to do is to, again, I'm going to go back to my 2 rules here that we had from the very beginning. You cannot have a fraction inside a radical, and more importantly, you cannot leave a radical in the denominator. How do we get rid of things that are in the denominator, radicals in the denominator? You do that by multiplying the top and the bottom by the radical you want to rationalize.